All right, we're going to talk about U substitution. U substitution really there's no calculus really involved. You use U substitution when you had a quadratic, such as in algebra 2 and pre-cal. If you had y is equal to x to the fourth plus 2x squared plus 1, and you kind of substituted u in for your exponent. And you had, like, let's say, let x to the fourth be the same as a squared, and then that means x squared is equal to a, and then you kind of like substitute it in. We're going to use the same idea, and you do that just to help clarify what's going on with the problem. It wasn't anything special. We're going to do the same thing in calculus. And so we're going to let u be g of x and du be g prime. And so we're kind of like, if you have like a complex function, we're going to be letting u equal the interior part of a complex function. So let u equal the inner function. We're going to find du and then solve for dx and substitute u and du into the integrand. I'll show you what I mean. So after that, everything needs to be in terms of u. If you have a leftover x, you need to solve for x is equal some sort of equation in terms of u. Go ahead and take the antiderivative, and then we're going to substitute the function x back in for u. So let me show you several examples on what I'm talking about. All right, if dy dx and f of x, if dy dx is equal to cosine of 2x, then y is equal to. And so if you want to look at, I'm talking about a function of functions. So I have a trig function. That's one function. And then I have an interior function, 2x. So I'm going to let u equal 2x. Well, if I take the derivative of both sides, if I take the derivative of u, that gives me du. If I take the derivative of 2x, that just gives me 2, and then the derivative of x. And so now I'm going to solve for dx. I'm going to divide both sides by 2. And so now I can substitute in. So dx is equal to du over 2. So if I want to take the antiderivative, I have cosine, and instead of writing 2x, I said that's equal to u, and I said that instead of writing dx, I said dx is equal to du divided by 2. And so notice I have no more x's in my equations. I've only have the letter u. So u now becomes my independent variable. At this point, it makes it a little bit easier to solve. So let me fix it so in a way you understand. I'm going to move my 2 in the front. And so that's like saying 1/2 cosine of u du. So at this point, I can just go ahead and take the antiderivative. Well, the antiderivative is 1/2, and the antiderivative of cosine, so what gives me a derivative of cosine? Well, we talked about that. That gives that sine. And notice I got an answer of sine, and so I don't need to worry about that negative. So it'll be sine of u. Okay, the du, just like dx, just kind of goes away. And then now I can do my plus c. But I can't leave things in terms of u. I need to resubstitute back in. Well, I told you u is equal to 2x, so we can go ahead and substitute back in. So 1/2 sine, instead of u, I'm going to put 2x, because that's what u is supposed to be, plus c. And now I'm finished. Alright, find the antiderivative of 9 times the quantity x squared plus 3x plus 5, that's all raised to the 8th, times the quantity 2x plus 3. And so probably the hardest thing that you need to find initially is what the heck is u? And so again, u is the innermost function. Another way you can think about it is what looks the most complex. And I'm guessing most of you guys are going to say, well, this whole thing looks complex. Yeah, but that's not an inner function. I'm looking for it on the inside. And so if you look on the inside of the parentheses, I can compare x squared plus 3x plus 5 versus 2x plus 3. And to me, the higher power is typically the one that seems to be more complex. And when that's true, my inner function is actually going to be that x squared plus 3x plus 5, because that's the most complex function. And if you take the derivative of it, you'll notice it'll be the same as 2x plus 3. And that's really important for when we do U substitution. So let's go ahead and let u equal x squared plus 3x plus 5. And so now we're going to take the derivative of both sides. So the derivative of u is du. The derivative of my polynomial is going to be 2x plus 3. I hope you see that right next to the dx. And then I'm going to multiply that by dx. So my next step is I'm solving for dx. I'm going to divide both sides by this quantity 2x plus 3. These guys will cancel. And so dx is equal to du divided by the quantity 2x plus 3. So now we can go ahead and substitute in. So this is equal to 9 times, and remember I had boxed around, this is going to be my new u. So it's u to the 8th times 2x plus 3. And remember we have dx. Instead of dx, we're going to write du. Divided by quantity 2x plus 3. And I hope you can notice that I have two objects that I can cancel. This guy and this guy. They're the same. So let's go ahead and cancel them out. And so I'm left with 9 u to the 8th du. And so now we can go ahead and take our antiderivative. That's going to be equal to u to the 9th. Our 9 is going to cancel, plus c. But I have to substitute back in. And so I can't leave everything in terms of u. So remember, u is equal to that polynomial. So that's going to be the same as parenthesis x squared plus 3x plus 5 raised to the, 9th, wrong number, plus our c. And now we're finished. Alright, number 3, find the antiderivative of sine squared of 3x and cosine of 3x. So let me rewrite this in a way that you'll understand. So most of you are not quite familiar with that. That kind of still screws you guys up. So let's go ahead and rewrite it. So if I rewrote this as sine of 3x quantity squared, makes it a little bit easier on what your inside function is, because you'll notice that this is inside of parentheses, and that's going to be our u. So let u equal sine of 3x. That means du is going to be derivative sine is cosine of 3x, and then I need to take the derivative of 3x, which is 3, and then finally the derivative of x is dx. So let me rewrite that. So du, well, let's move the 3 in front. So 3 cosine of 3x dx. Well, now we need to solve for dx. So let's divide both sides by this quantity, 3 cosine of 3x. These guys will cancel. So dx is equal to du divided by 3 over, du over 3 times cosine of 3x. So let's go ahead and substitute in. Okay, my sine of 3x, that's my u. Then cosine of 3x. And instead of writing dx, let's write our du. So this is going to be du all over 3 times cosine of 3x. Well, I hope you notice that your cosines are going to cancel. And so let's rewrite this so you can see what we have. That's going to be equal to, let's move the 3 in the front, so that gives me 1/3 u squared du. And so now we can take our antiderivative. So antiderivative of u squared is going to be u to the 3rd plus c. And so let's multiply our coefficient. So we have 1/9 u to the 3rd plus c. But again, we can't leave things in terms of u. We have to substitute back in. So we have 1/9 sine of 3x to the 3rd plus c. And we can just leave it in that form.